We talked about the idea of population data versus sample data. We can also break data into qualitative versus quantitative. If our data consists of values that cannot be ranked, then we refer to that data as qualitative. So when the responses don't have a numerical value where we can say one is larger than the other, it's questions like favorite color, eye color, favorite brand of sneakers, something like that. If our data consists of values that can be ranked, so one result is definitely larger or smaller than another, we refer to that as quantitative data. These two words can sound very similar, but one trick for keeping them straight is at the beginning of the first word almost has the word quality in it. So we're talking about a quality, something that can't be ranked or compared against another value, versus quantitative almost starts off with the word quantity. So we are getting values that we can rank and compare against one another. Another way to keep them straight is to look at some alternate words for these terms. So qualitative data can also be referred to as categorical data. So the responses or the data that we capture just puts answers in a specific category where one is not better than another necessarily. And quantitative can also be referred to as numerical data. Again, we're ending up with numbers that we can rank and compare against one another. In example 2, if we were to collect information on the number of students enrolled at a college, the data collected would be an example of, in this case, quantitative data. In example 3, if we were to collect information on the length of baseball games, the data collected would again be an example of quantitative data. In both cases, we're ending up with numerical values that we can compare. If we either had, obviously, 100 students enrolled at a college or 1,000 students enrolled at a college, we know which one of those is larger and smaller. The same if we talk about length of baseball games. If it was 1 hour long, 2 hours long, we can compare those results. But there is a distinction that we can add between these two types of quantitative data. In example 2, we have what we refer to as discrete quantitative data. When we talk about enrollments at a college, we either have 1 or 2 or 3 and so on, obviously up to much larger values, but we don't get any values in between. We can't have 1.5 students. It's either 1 or 2 and so on. Versus in example 3, when we're talking about the length of baseball games, we have what we refer to as continuous data. A baseball game could be 1 hour long or 2 hours long, or something in between. It could be 1 hour and 10 minutes, 1 hour and 5 minutes, and we could get smaller from there. It could be 1 hour, 5 minutes, and 30 seconds, 1 hour, 5 minutes, and 2 seconds, and then in between seconds, we have tenths of a second, hundredths of a second, which in terms of the length of a baseball game doesn't really maybe seem to matter much, but if we were talking about timing a race, races, especially at the Olympic level, could often come down to tenth of a second, hundredth of a second differences. So continuous data is where there aren't these hard numbers. We have the values in between that we can consider as well. Versus in example 2, we can't have a fraction or a decimal component of a student. In example 4, if we were to collect information on people's favorite brand of toothpaste, the data collected here would be an example of qualitative data. While obviously everyone might have a favorite brand, you might not care, and whoever's researching this might have an interest, a brand that they prefer, especially if you work for a company that produces toothpaste, but there's no ranking of the different answers here. All the answers are just different categories that we would lump people into based off their response. But there's no numerical comparison between those different answers.